So, the CLO for this lesson is students will be able to solve in writing for x using quadratics factored form in the zero product property, as well as the following language: if then statements, quadratic, isolate, factored form, factoring, and zero product property. So, the first vocabulary word is just a reminder that we are always doing this with quadratics, specifically the ones that have x squared as their biggest exponents. And then when we solve for x squareds always have two answers. So we're solving for x with quadratics, but this time we're doing it in factored form. So let's talk about it. The first vocabulary word on the list is isolate, which is just the big way to say solve for or to get alone. Factored form is a specific quadratic form that looks like this: parentheses x plus some number times x plus some other number. And we call them D and E. The reason why it's called factored form is because of the word factor. What the word factor means: a factor is something that multiplies to something else. So for example, this times this would equal the big standard form one. So these are both factors because when I multiply them together, they equal something bigger. Another way to think about it is like if you have 15 factors of 15. Factors of 15 are, for example, you can have 1 times 15. So those are both factors. You could also have 3 times 5. And so 3 and 5 are known as factors of 15 because when they multiply together, they become 15. And so that's what the word factor means. So this is called factored form because this multiplied to this parentheses would equal the big standard form. Next, we have zero product property. So 0 is the number 0. Product means multiplied. So, because product is just the big word to multiply. And 0 multiplied to anything is what? 0. Anything times 0 is 0. And that is the zero product property. And that's important. So, for example, if I have 5 times 0, 5 times 0 is 0 because of the zero product property. Same thing if I do 3 times 0. 3 times 0 is also 0. It doesn't matter if 0 comes first or second. Anything times 0 is 0. So much so that even if I have all of this being multiplied together, 5 times 6 is 30, times negative 2 is negative 60, times 0 is 0, times 4 is still 0, times negative 3 is still 0. Because anything times 0 is 0. And that's the zero product property. And the reason why that matters is because if I want to try to solve something like this for x, so let's say it says solve for x. Well, my problem right now is that it's this parenthesis times this parenthesis. So let's say I go ahead and make my equation equal 0 like I'm supposed to. And I'm like, okay, I want to solve for x. If I try to do backwards PEMDAS, the problem is that there are two x's right now. So how are you going to solve for just one of them when there are two of them? So you can't do backwards PEMDAS. So instead, we're going to use the zero product property to help us solve. Because if I want all of this to equal 0, well, remember, it's this parenthesis times this parenthesis. So for example, if this parenthesis right here somehow equaled 0, it doesn't matter what this one is because the answer is still going to equal 0. So how does that parenthesis, that x minus 7, how am I going to get it to equal 0? Because I want this parenthesis right here to be 0 to make this work. Well, to solve for x, how do I undo subtracting 7? I add it to both sides. So over here, this -7 plus 7 cancels. So I'm just left with the answer that x would equal 0 plus 7, which is 7. So that's one of my answers, because remember when we solve for quadratics, it always has how many answers? It always has 2 answers. So where's my second answer coming from? Well, if 0 equaled x minus 7 times x plus 2, if I put 7 into the x's, what happens is 7 minus 7 becomes 0, like I wanted. 7 plus 2 becomes 9. And 0 times 9 is still 0. So that is one thing that when I plugged it in for x, it made the equation equal 0. But if I go backwards, and if this one equaled 0 instead, so if this x plus 2 was the 0, then whatever this is times 0 will also equal 0. So if I take x plus 2, and it has to somehow equal 0, well, to do that, to get rid of the plus 2, what do? I subtract it away. So that I'm left with an answer that x equals 0 minus 2 is -2. So then that's my second answer. 0 equals x minus 7 and x plus 2. If I'm telling you x is -2 and I put -2 into both of these, -2 minus 7 is -9. -2 plus 2 is 0. And -9 times 0 is 0. So this is another answer that when I put it into the equation, I would get an answer of 0. So my two answers are x equals 7 and -2. Those are my two answers when I solve this one for x using the zero product property. All right, let's do another one. So remember, each parentheses has to equal 0. But this x isn't in a parentheses, but I can put it in a parentheses. And I could put plus 0 in here, but I don't have to. I can leave it like this. The important part here is my two answers come from when each parentheses equals 0. So when x equals 0, and then when 3x minus 12 equals 0. I have to solve them both for x. Here's the thing about trying to solve this one for x. X is alone, meaning x equaling 0 is an answer. And that makes sense, right? If I put 0 right here and 0 right here, 3 times 0 is just 0. 0 minus 12 is just -12. But it doesn't matter because when I multiply it to this 0, my answer is going to be 0. So that's just one of my two answers. To solve this one for x, which one do I get rid of first, and how do I do it? Let me get rid of the minus 12 by adding 12 to both sides. So then I have 3 times x equals 0 plus 12 is 12. And don't forget these two canceled. So finally, how do I get rid of this 3? By dividing it away. 3 divided by 3 is just going to be cancel and become 1x. So 1x is going to equal, and then 12 divided by 3 is 4. So that's my second answer. So the answer is x equals 0 and 4. Those are my two answers when I solved this one for x. And using the zero product property. So what if it doesn't start in factored form? Well, it could start in standard form. And to go to factored, we use something called factoring. And if it started in vertex form, first I'd have to go to standard by distributing. Then I'd go to factored form by using factoring. So ideally, in the first half of this class, you learned how to factor already, and you learned how to distribute in math a couple years ago. So you should know how to convert already, but just in case, I'm going to remind you. So this is how factoring works. 1. Divide out any greatest common factor, also known as your GCF, greatest common factor. All right, so this factoring example is way harder than you're actually going to have to factor in this class. This one isn't even a quadratic, it's a cubic because the biggest one's an x cubed instead of an x squared. So first, you have to make sure to do factoring that you have quadratics. And you want to also make sure that you take out any greatest common factor. Remember, factor just means what you can divide by, and the greatest common means it has to be the same for all 3 of these terms. So let's break them apart into factors. So 6, when I divide 6 by 2, I get out 3, and it's a prime number, so that's divided into its 2 factors. And x cubed means x times x times x. So these are all the factors of 6x cubed. Then I have a negative 14. When I divide 14 by 2, I get out 7. And 7 is a prime number. It can't split apart anymore. X squared means I have 2 x's. Plus, when I divide 4 by 2, I get out 2. And then I have 1x. So the greatest common factor is the biggest number in all of them. So if it's in all of them, I can divide it out front. So see how there's a 2 right here, a 2 right here, and a 2 right here. So they all have a 2. So they all have this, a 2, a 2, and a 2. They don't all have a 3, but they do all have an x. They don't all have another x, though, because this one doesn't have a second x to grab. So that's it. So my greatest common factor between all of them is a 2 and an x. So I'm going to divide that out front. I'm going to take them out of each one. So if it's not here anymore, and it's not here anymore, because I took it out of view, and I take it out of view. I take it out, and then I have to put a parentheses, because since I'm dividing it out of all of these, then all of these have to be together in a parentheses now. And this one's left with a 3 and 2 x's, and that would be an x squared. This one has a minus, and then a 7, and then only 1x. And then this one over here only has the plus 2 left, because I pulled out a 2x out of each one of them. So I've done step 1. I've divided out the greatest common factor and put it in front. And then the rest is in a parentheses, because if I distribute this back into each one of these, it would go back to this. It's the same thing. This is just when it's divided out. This is after it gets multiplied back in. So now, step 2 is to take the quadratic equation and set up the factoring box. So this is how setup goes. There's this box, and inside the box, when you take this quadratic equation, this part only, not the 2x. The 2x isn't a part of the quadratic. So I'm going to take the quadratic part only. And then in this first box goes a x squared. And then in this last box is the c. And it always is going to look like this. So if I do it for my example, I have 3x squareds, and my c, my last number, is just a 2. Step 3 is to find 2 numbers that will multiply ax squared times c. So whatever these 2 multiply to, the 3x squared times the 2, in this case, 3x squared times 2 equals 6x squared. But I need two numbers that will multiply to 6x squared, but add to bx. So I need two things that are going to multiply to 6x squared and add to whatever my b was, and in this case, my b is negative 7 x's. So here's the thing about both of these boxes, these two missing boxes here. This one's going to be one of the two numbers, x. This one's going to be the other one of the two numbers, x. Because they're both x's, x times an x will end up going to x squared. When you add them, they will be x's. So you can also think about it, instead of thinking about the x part, you can think two numbers that multiply to the whatever a times c multiplies to and adds to the b. And you don't have to think about the x parts as long as you remember this is always an x and this one's always an x. And it doesn't matter once you find the two numbers where you put them, like which one goes here and which one goes here, that won't matter. But let's start listing things and try to figure out what it is. So things that multiply to 6. Well, if I divide 6 by 1, one option is 1 times 6. I divide 6 by 2, I get the answer of 3, and so 2 times 3 is 6. And then if I tried dividing by 3, I would get out the answer of 2, and I don't need that one because I already have 2 and 3. So once I hit a number I already have, then I know I can stop. So since this was 2 and this was 3 and my next guess was 3, I don't even need to try 3 because I already have that answer and I'm done. So which one of these somehow is going to add to negative 7? And it can add or subtract. So if I take, for example, 1 and 6, if I add them, I get 7. Look at that. It's probably 1 and 6. But let's say I didn't start with the right one. Then I would also try 1 minus that 6, which is going to be negative 5. So it's not going to be negative. I would also try 2 plus 3, but that's only 5. And if I tried 2 minus the 3, then I'd get negative 1. And I want the pair that gets me to 7. So that was that first pair. So it's going to be 1 and 6. Now I just have to check the signs, though, because if I do positive 1 and positive 6, when I add 6 plus 1, that's positive 7, not negative 7. So what if they're both negative? Well, if I check it, negative 6 minus 1 is negative 7. And since they're both negative, they will still multiply to a positive 6 like I want, because this 6 is a positive one. So now I know I'm good. So quickly to remind you of the sign rules, if A times C is positive, both numbers have to have the same sign. So they're either both plus or both minus. Because as long as it's the same, a positive times a positive is positive, and a negative times a negative is positive. So since it's multiplying to a positive 6x, they're either both plus or both minus. But since the b was negative, they both had to be minus. Versus if a times c ends up being negative, the signs are different. One is plus, the other is minus. And you would have to play around with it and figure out which one's which. My next step, step 4, is to figure out sides by factoring out. So what I mean by that is when I'm going to factor, I could either factor up and down like this, or I could factor side to side. Let's go with up and down. So between 3 and 1, the biggest number that divides into both 3 and 1 is just 1, because 1's the only thing that multiplies to 1. This one has an x, this one has 2 x's, so I can take out 1 of the x's. Then over here, 6 can divide into -2. So a negative times 2 times 3. And then you still have the x. So they both have a 2 in it I can factor out. So I can take a 2 out of both of them. So then I took the 2 out of u, took the 2 out of u. But they don't both have an x for me to pull out, so I can't pull it out. So then on this side, this has to be something when I multiply it to this, it equals this 3x squared. So this is 1. What times 1 will give me 3? 3. And if they took one of the x's away, this one has to have the other x in it. So then does it work for this box? Well, 3 times 2 is 6. It's not negative yet, though, so that's a problem. Can this one be negative? No, because this is a positive, so maybe this guy has to be the negative one. So now -2 times the 3 is -6. And then this one has the x on it. So then I get the x. So this negative actually went away up here with that one. And then 3x is what I had left to go over here. So now when I do 1x times something to get -1x, best way to think about it is this 1 was taken away when it went up there. This x was taken away when it went up there. So it has to be negative and then 1. Because -1 times 1 will still give me this 1, and then the x comes from there. So now, finally, if this is -1 and this is -2, is -1 times -2 positive 2? Yes, it is. So then that works out well, like we want it to. And so finally, the answer in factored form ends up being, this side is its own parentheses, the top. So I have 1x minus 2. I don't have to write the 1. Times, on this side, is 3x minus 1. So now it's in factored form. Because if I multiplied it back out, I would end up this with this, which combines to my original answer all the way up here. Well, this part. And then I still have that 2x from the beginning. So actually my answer has to have that 2x in front of it to make it the exact same as the very original one. Because I can't forget that the first thing I did was factor out that 2x. And then I factored it even more using the factoring box to get this times this. If the question had asked me to solve for x, then I would have had to make 2x equals 0 and solve, this parenthesis equals 0 and solve, this parenthesis equals 0 and solve. And then I would have ended up with 3 answers for x for this one, since I have 3 different parentheses, because this one's like in an invisible parentheses. So, but that's not what it asked me to do. This one at the top, it was just explaining factoring. So now let's do some big examples. So this one, it says use factoring to put the equation in factored form. So I have to do that first. And then use the zero product property to solve for x. Right, step 1 would be to divide out any greatest common factor that we had. So if I tried to do that, x squared means x times x. -7, 7 does not split apart anymore, then you have x. Plus 10, once you divide it by 2, you get an answer of 5, which is also a prime number. So is there any term that's in the same for all 3? This one has no number, so there would be no number that's the same for all 3 of them. This one only has x's, 2 x's, this one only has 1, and this one has none. So there is no greatest common factor to divide out. For quadratics, unless there's a number in front of this x squared, there is not going to be one because the last number doesn't have any x's in it. And if the first one doesn't have any number in it, besides the 1, that's always there invisibly, then there is no greatest common factor to factor out. A lot of the times there is not one, but sometimes there is, and so you always got to check first. But for this one, there's not. So then I get to skip to step 2. So the ax squared goes here. Remember, if there's no number in front of that x squared, it's just a 1. And then the c, the number at the end is what? 10. All right. So I need 2 numbers that multiply to a times c. And a times c right now. A is what? 1. And what is c? 10. And 1 times 10 is 10. So I'm going to need 2 numbers that multiply to 10, but add or subtract to the b. And the b right now in this equation is -7. So first, I'm going to list everything that multiplies 10. If I divide 10 by 1, I get out an answer of 10. If I divide 10 by 2, I get out an answer of 5. If I divide 10 by 3, I get a decimal. Decimal. If I divide 10 by 4, I get out a decimal. And I don't have to try 5 because I already know the answer from 5 will be 2. So I'm done. These are the only things, the only 2 pairs that somehow multiply to 10. So now they have to somehow add or subtract to -7. Let's talk about the sign rules. A times c, was it positive or is it negative right now when I multiplied a times c? I got a positive 10, which means both of the numbers, whichever pair it is, have to have the same sign, either both plus or both minus. Which means if I take these and I test that, either they're both positive, like this, or they both have negatives in front, like that. Same thing here, either they're both positive, so I add them, or they're both negative. There's minuses. Now I know that they're either both plus or both minus because when I multiplied a times c, I got a positive number. And 2 positives make a positive and 2 negatives make a positive when you multiply. So now let's see when I add and subtract. 1 plus 10 is 11. -1 minus 10 is -11. So my goal was to get to 7 though. So it's not these 2. If I do 2 plus 5, I get out +7. However, I want it to be -7. So if I do -2 minus 5, that's when I get out -7. So my 2 numbers are these 2. It's -2 and -5. So I know it's -2 and -5. So then when I go back to my original box, the 2 numbers here are going to be, it doesn't matter which one goes where, but -2 I'm going to put there, and -5 I'm going to put there. So again, it doesn't matter if you like to factor up first or sideways first, but I'm going to go ahead and factor up. So one way to do this is to remember that x squared is the same thing as x times x, and then -5x is the same thing as just a -5 times an x. -2x is just -2 times an x. And 10 can split apart in many ways. It could either be 1 and 10 or 2 and 5. But since this one has a 2 and this one has a 5, I'm going to use 2 and 5. So for greatest common factors, I'm going up and down. Is there a number in both of these? No, this one's -5 and that one doesn't have a number, or it's a 1, invisible 1. Is there a letter that's in both of these? They both have an x that I could factor out on top. So by doing that, it kind of gets rid of one of the x's from each of them. Then if I factor up this way, they both happen to have at least a 2. I don't know if it's going to be negative or not. So that gets rid of the 2 part, but I'm going to leave that negative right there. And is there a letter for both of them? No, there's not. So then if this took one of the x's, what does this one have to be to make it work? Well, this other x right here. So this is going to be u. But then I have to also take the x out of this other guy, which means both of these are gone now, which is great, but the minus is still there. It's still a negative. And right now, neither one of these are negative, so they're not multiplying to the negative 2. So if I put it on this one, it's a problem because this is a positive x squared. So I'm not going to put it on u. I'm going to go ahead and put it on this 2 then. So then the negative will go away as well. So if this is negative 5x, and then the x already went right here, what does this have to be to multiply to negative 5x? It needs to be this negative 5. So then that's going to go away here, and here the 5 is going to go away. But the weird part is the 2 negatives. Well, since they're both negative, a negative times a negative will still be that positive 10. So now I've divided and factored everything out to the sides to realize that my answer is that the equation equals, the top says x minus 2, and the side says x minus 5. So now I have factored this equation up here. This was in standard form. Now it's in factored form because I factored it. These are the same thing. And if I were to multiply this back out, it would turn back into this. But now I can use the zero product property. Use the zero product property to solve for x. So if I take this equation and I set it equal to 0, it will become 0 as long as what? As long as each parenthesis equals 0 by itself. So how do I make this one? How do I solve for x here? I have to add the 2 away to both sides. So these will eliminate. So then x equals 0 plus 2, which is just 2. And then to solve for x here on this one, what do I do? I have to add the 5 over. So they eliminate from here, but I have to do it to the other side as well. So that I find out that x would equal 0 plus 5, which is just 5. So now I figured out that my two answers are x equals 2 and 5. And that would be my answer for this one. And to just go check those instructions really fast. Use factoring to put the equation into factored form. We did that. And then use the zero product property to solve for x. We did that and got our answers. So we've done the whole question and we're all done. For our last example, we have to start by first putting the equation in the standard form. What form is this equation currently in? It's in vertex form. And to go from vertex to standard, all you do is you distribute out the parentheses being squared. So to multiply it out, I have a couple of choices. So this time around, I'm going to go ahead and use the box method for distributing forward. So the way the box method works is you take one of them, you put it on the side. So the first term goes here for this first row. The second term goes second for the second row. Then you take the other parenthesis and you put it on top of the box, where again, one of the terms will go in the first column. The other term, the -4, will go here in the second column. Now you multiply the sides to get the middles. For example, this box right here will come from this red x getting multiplied to this blue x. So this blue x right here will go to this box and over here to this box. And then this -4 is going to go in this box as well as over to this box. And then the red ones, this x goes here and in the other one beneath it when we multiply. And this -4 also goes to both of the boxes beneath it. So when I multiply them out, the x times the x becomes an x squared. -4 times the x is just -4x. Again, x times -4 is just -4x. And finally, the -4 times the -4 becomes a positive 16. So then, after multiplying it out, my answer becomes everything in the middle. So I have the x squared, a -4x, another -4x, and then a positive 16. But that was just these two parentheses. I can't forget I also had this -25 at the end. So now to finish it out to get it into standard form, I have to combine like terms. So this is the only x squared in my whole equation. So it has nothing to combine with. It's just x squared. But here's -4x's, and here's another -4x's. And -4x minus another 4x's is -8x's. Then finally, plus 16 minus 25. If you were to put it in a calculator, you'd get -9. So now we are in standard form. So we did our first step in the instructions, because it says first, put the equation into standard form. But now we have to factor it to factored form. So here's our equation. These are the steps for factoring. First, I need to divide out any greatest common factor, or the GCF. There's no number in front of this x besides the invisible 1, so there's no number in all of them. The last one does not have an x, so there's no letter in all of them, so there is no greatest common factor. All right, step 2, I gotta take my equation and set it up in the factoring box. This is my equation. What's the A? It's the 1, because it's an invisible 1. And what's my C? What's my last number? -9. So I'm starting the setup. Next, I need to find two numbers that multiply to the A times the C. So A was 1, and C was -9. And 1 times -9 is -9. So I need two numbers that also multiply to -9, but we'll add to the B. And the B right now in the equation is what? It's -8, because that's the number before the x's. So now I shall start listing everything that multiplies to 9. And I'm going to ignore the fact that it's negative right now. That's going to come up in a minute. But everything that multiplies to 9. So if I take 9 and divide it by 1, I'm going to get 9. And then if I try dividing by 2, I get a decimal. If I do 9 divided by 3, I get the answer of 3. And since I hit 3, I'm done. There are no more. So these are my two pairs. So somehow these pairs, they all will multiply to 9. Well, it's not quite 9 that we want them to multiply to. We want them to multiply to -9. Well, to do that, let's look at our sign rules. If A times C is negative, the signs are going to be different, meaning one has to be positive and one has to be negative. It doesn't matter when we multiply if this one's the negative or if this one's the negative. But only one of them can be negative and the other one has to be positive to multiply to -9. To know which one's going to be which, we're going to think about this part, the fact that it needs to add or subtract to -8. So what I'm going to do is I'm going to take everything, so 3 and 3 will multiply to 9. So let's say this one's negative and then this one's the positive one. We have to wonder what's going to happen. Also, if this one's the positive one and this one's the negative one, we have to figure out what's going to happen there too. And then we have to do it for 1 and 9 too. So we could start with the 1 being negative and the 9 being positive and figure out what they equal. Or I could switch it with the positive one, -9 with the positive one, and figure out what that will equal. So one of these pairs has to somehow get us to -8. Let's see. If I do -3 and I plus 3, I get 0. So that's not it. If I do +3 and then I subtract 3, I get 0 as well. So it's not that one. If I do -1 and then I add 9, I get +8. So that's almost right, except I want it to be -8. So then if I do the 9 being negative with the 1 being positive, that's how I get -8. So when we scroll down to our box, we have to put -9 somewhere and +1 somewhere. It doesn't matter which one we put where. Let's say I put the -9 here and then the +1 here. So if I were to break these apart into their factors, 1x squared just means you have an x times an x. I don't even need to write the 1x squared. I could put the 1 in front if I want to. I don't have to. 1x just means we have an x. Again, I could also say there's the 1 in front, but we don't have to put it there. -9x means we have an x, a 9, and a negative, all being multiplied together. A -9 just means we have a 9 being multiplied to a negative. It could also be, I could split that part into 3 and 3, but since the other ones aren't 3, I'm not going to. So now if I factor out, is there a number in both of these up and down? Yes, there's the 1. I don't have to write it though. Is there a letter in both of these up and down? There's an x. So if I take an x out of both of them, it's like they're gone. Going up and down here, what's in both of them? Well, they both have a negative that I could take out. They both have a 9 I can take out. However, they don't both have a letter. So then now, going side to side, if this one's the x, this one has to be the other x right here. And it's this x right here too. And if you check, -9 times x is -9x. Then for down here, there's no more x, and the only thing that's left is just this 1. There's not even a 1 in this box, but there's always an invisible 1, because 1 times 9 is still 9, right? So all that's left in both of these is the 1, and if I check it, -9 times 1 is still -9. Now I factored out my expression. I get a final answer that my equation equals, and on the top it says what? X minus 9, and on the side it says what? X plus, because it's a positive, 1. So now that I have it in factored form, am I done? Let's go check the instructions. First, put the equation in standard form, then factor it to factored form. Oh, then I still need to solve for x. So I'm not done, because now I need to solve for x, and when it's in factored form, how do we solve for x? We use the zero product property to solve for x, which just means to take each parenthesis, like x minus 9, and make it equal 0. And then take the x plus 1 from the other parentheses and make that one equal 0. So to solve for x, how do I isolate x in this first one? By adding the 9 away, because negative 9 plus 9 eliminates. When I add 9 to 0, 0 plus 9 is just 9. So x is going to equal 9. For this one, the x plus 1, how am I going to isolate x? By subtracting the 1 away, because those eliminate. But then 0 minus 1 is going to tell me that x is going to equal negative 1 for my second answer. So my two answers are that x is going to equal 9 and negative 1. Come up here. And then that's going to be the answer for this one. So using if-then statements and the vocabulary words quadratic, isolate, factored form, factoring, and zero product property, explain what you learned how to do in this lesson.